Electricity. The word electricity itself is electrifying us. The reason is quite simple. We can't imagine a day without electricity. Let's see the illuminated city by using electric current. Why this electric current has become so famous? Although it has been discovered just recently, over 100 years, the reason is quite simple because of its uses. Let us study how electricity is useful in our daily life and what is the basic thing in electric current. We know that electricity plays important role in our lives because of its convenient form of energy and because of its transformation to various other forms of energy easily. We know we get light, our fans rotate, we can watch a TV, can run a motor, charge a mobile also, we can heat a room or cool a room. These all things can be done just by electric energy. There is no other energy which can be transformed so easily, so conveniently like electric current. That's why it is most popular. Let us try to list out various gadgets which use electric current. This slide is representing how the energy transformation takes place by using electric current. Electric current can be used to get heat energy. It can be used to get light energy. We are watching TV with electric current. We are heating or using cooking instruments by using electric energy. Bulbs are glowing. A glowing bulb will produce heat energy, light energy also. Then, if we take the energy transformation in a car, we can find out electric energy is getting transformed into various other forms like mechanical energy, electrical energy, chemical energy, light energy, sound energy, etc. So that is its speciality. We know now electric current is very much useful in all our activities. Then what is electric current? Electric current is simply the flow of electrons. How electrons will flow? Why do they flow? Just imagine you want water to flow. How it will flow? It will flow from a region or from higher altitude to lower altitude easily, like using gravity. Similar way, current also will flow from higher potential to lower potential. What is higher potential? Higher potential is the region where the electrons are more. The region where the electrons are less is having the lower potential. The electric current will flow or electrons flow from a region of higher potential to lower potential. You have seen a battery cell. Take it out, find its positive and negative terminals. When you put in a torch, you know that a bulb will glow. So indicating that now current is flowing through that. Electrons are flowing. So in a battery cell, which end has more potential? How current will flow? Just try to find it out. Surely current flows from higher potential to lower potential. So in the same way, if there is equal potential on either sides, what we can expect? Definitely no current will flow. Just observe the figures. In the first figure, water level in the first tank is more and the second tank has less water. We can easily predict the water flowing from tank 1 to tank 2 as far as the water level becomes equal in both. But in the figure 2, You can't expect water to flow from first tank to second or second to first because both are having equal height of. It is very clear. So it is very clear that electrons flow from a region of higher potential to lower potential in the electric field. This is known as electric current. Simply, electric current we say as flow or the drift of charges. What is the unit of electric current? So it is measured in amperes. The SI unit of electric current is ampere. Electric current is the ratio of quantity of charges flown in given time, I equal to Q by T. Where Q is the quantity of charges flown and T is the time in seconds. The SI unit of electric charge is coulomb. Just go through the example 12.1 in your textbook, page 94. Try to find out the current flowing in the circuit. Till now, we are discussing that electric current will flow when there is a potential difference. Potential difference means what then? It is the amount of work done in bringing unit charge from one point in an electric field to another. Or similar way, just imagine electric current or electron flow from a region of higher potential to lower potential. There will be difference in potential between these two regions, and that is potential difference. We can mathematically represent V equal to W by Q, where W is the quantity of work done and Q is the quantity of charges transferred in given time. If 1 joule of work is done in moving 1 coulomb of charges, then we can say voltage or potential difference is 1 volt. What is the meaning here? Here, SI unit of potential difference is volt. In common, potential difference is called as voltage. In this figure, just observe. We have a simple electric circuit. What is electric circuit? Electric circuit is a path where current flows. It's a closed path in which current moves. So refer the symbols used in electric circuit in your textbook. Here you have a simple circuit. There is a battery, a bulb, and a connecting wire. This is said to be the simplest circuit. Try to draw this circuit in your. Observe these two figures. Here we have ammeter and voltmeter connected in the circuit. Just ammeter measures the flow of current, which is measured in amperes. Voltmeter measures the voltage, which is measured in volt itself. And a resistor you can observe in the circuit. A resistor is a load which offers resistance to the flow of current. We are having TV, we will have fridge, washing machine, etc. They all are resistors. They offer certain resistance to the flow of current. In turn, they cause heating effect also.
Verification of Ohm's law. George Simon Ohm, a German physicist, established a relation between the current flowing through a conductor and the potential difference at its ends. This relation between potential difference and current is called Ohm's law. Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference across the ends of the conductor, provided the temperature remains constant. That is, V is directly proportional to the current flowing through the circuit, or V is equal to Ri, where V is the potential difference, R is the constant of proportionality, called the resistance of the conductor, and I is the current flowing through the circuit. R is equal to V by I is the mathematical representation of Ohm's law. Shown here is a circuit with a suitable voltmeter for measuring the potential difference V across a resistance box Q and a milliammeter for measuring the current I flowing through the resistance box. A rheostat is used for varying the current and potential difference in the circuit. Click on the key to close the circuit. Record the values of V and I in the observation table. Now vary the position of the slider of the rheostat and record V and I. Record at least 5 values of V and I by adjusting the position of the slider of the rheostat. Calculate V by I in each case. The value of V by I is found to be equal to a constant R. which is the resistance of the conductor, thus verifying Ohm's law. This holds good only if the temperature remains constant. The unit of resistance is ohm. The Greek letter omega is used to represent the unit of resistance, ohm. Click on the link provided to remember the relation between V, R and I. A simple way to remember Ohm's law is to visualize the triangle VRI. For finding the value of any of the variables, simply hide that variable and get the value of the hidden variable. Thus, when we hide V, we get R into I. Hence, V is equal to R into I. Similarly, if we hide R, we get R is equal to V by I. And if I is hidden, we get I is equal to V by R.
Current flowing in a circuit is governed by Ohm's law. Ohm's law states in a simple way that current flowing in a conductor is always proportional to voltage along the circuit or the conductor. That means V is proportional to I, but V is not equal to I. The reason is simple. Every conductor will offer certain resistance to the flow of current. That's why we say V equal to I into R, where I is the current flowing through and R is the resistance of the conductor. So if you increase the voltage, you can find out the current flowing in the circuit will increase when keeping the resistance constant. Here is a video to explain Ohm's law more